Okay, so we are back online. Today we'll continue with the mail pilot. Just two more things that I want to show you. One is coroutines and how you can use coroutines to do different things. And then we'll review quickly the scripts that we did before to get ready for the midterm, right? So I downloaded the project from Blackboard from week 5. Let's open it right now. Start Unity.
Complain about quiz 2. Right. Sorry.
Later.
Later. Okay.
Okay. Well, waiting for the unit to start, right? Skip this version. Let's open our scene. Surprisingly, our labels traveled a little bit too far outside of the screen. Right, so that's what we have right now. Right, we have a music, we have our plane flying. If we collide, there should be an explosion. That's why I'm surprised. I used the same project in the previous lab and it was working. So let's figure out let's check what's wrong. Rocket is tagged. Scripts. Rocket control. Visual Studio. I forgot about that. Let's switch to mono. Collisions. Game controller. Lower the volume. Let's see what's going on. So we have collision with enemy. The lives are taken, but we don't have animation. We don't have animation. Let's see why we don't have animation. We should have. Oh, we can always add animation. I downloaded the project from wrong week. So I will add animation, game object, explosion, right? And what we have to do with, oh, I have explosion. Wait. Instantiate explosion. Here it is.
Have it in your animation folder?
Just a second. I will do one thing and we'll explain the whole process. What I'm doing right now, I want to debug my code. Animation. We did animation last week. We have used the sprites that we downloaded from the asset store, right? The atlas that we have there. Animation was created simply by drag and drop action, right? You select all the frames, you drag it to the scene. It creates two things. It creates explosion click, which is the sequence of frames, and the controller. And because it's a simple animation, no states, right? We are not changing the animation in any ways. That was all that we did. We've added a script, very simple script with explosion. One function, destroy me, that is destroying the object, right? The game object that plays the explosion. And then we saved everything as a prefab here, right? This prefab then is instantiated by the plane collision script, right? It places the script on the map, in the scene, right? The script plays, so we see the explosion, and then the explosion script triggers and destroys the object, right? So that's the logic behind. I'm trying to figure out why this script didn't work on our scene. I have one suspicion. Let's check, of course. Let's make it 2. Ordering layer for our explosion prefab was set to 0. So probably explosion was happening underneath the sea. That's why we didn't see it. One rocket. Yep.
Actually, it showed to me under your hierarchy, one of the game objects is event system.
Yes.
It's created automatically.
Event system is created automatically with Canvas, and it is part of the way how Unity handles interactions with UI.
Oh, okay, I deleted from mine.
It should be there, right? It should be there.
Okay.
Otherwise, you will have issues with UI, especially with fetching the clicks. Okay, so that's our project, right? It's working. What I want to do? I want to do one thing. I want make my plane to blink when I hit the rocket. You know, kind of remember Mario Bros. Whenever you hit something or something bites you, you start blinking, right? So I want the same special effect in my game, right? So what I will do, I will go to the plane collision script. Let's make it let's make our view a little bit bigger. I mean the font a little bit bigger so you can see it. And that's better. What I want to do, right? I have this function on trigger enter 2D. This is where I detect all collisions, island, enemy, whatever, right? So I know that I want to do something in this section when I collide with enemy. What I will do, I will create a function, blink. This function is not created, that's why it's red. So let's add the function. Private void blink. Okay. What do I need to do? I need to play with alpha channel of my plane. And I'm a little bit lazy today. So I have some snippets prepared. So I have to type a few things. I will move the declaration of the color outside of this loop. I will also declare a renderer. And this is, of course, the component from the game object, right? So game object, game object dot get component renderer. Renderer is this component that allows us to access or modify the way how sprite or anything else is rendered, painted on the screen, right? One of the properties or one of the elements that renderer has is the material, and material is element that is really handling all the colors, images, and so on, right? So through material, we can access color, and we can play with A, and A stands for alpha, right, for transparency. What we are doing here, we start with 1, so it's fully opaque, and we are going slowly down, right? Seems correct? Let's see the effect. Save, build.
Sorry, Tony, what is the A property again?
It's alpha channel. It's transparency.
Okay.
So you have RGB
Yes.
and A, right? Okay, so I'm playing my game again. Let's hear the funny music. You can see me, but it wasn't a gradual change, right? It was jump from 1 to 0.1. So that's not the way how we want to do it. Why this is happening? Why this kind of behavior happens? Why we are jumping straight to down to 0.1? Because the, sorry, go ahead.
Because the loop is happening on just one frame.
Exactly, because we execute the whole loop within one frame, right? So in one frame, you're visible. In the next frame, you're not. What we need a way to make it visible, right? So basically, we need a way to step out from the loop, render this the image, get back, change, and so on, right? And that's why we have coroutines. Coroutines are special functions. First of all, they return something. They return enumerator, funny type, and they also have a bunch of funny return statements, because those return statements are in weird places. Normally, you wouldn't do something like that. Normally, you wouldn't put a return statement inside the loop because it doesn't make sense, right? This return, like that, I mean, okay, you go through the first loop and then you exit, right? But we have additional keyword, yield. Yield allows us to get back to this loop. It's kind of step out, step in place, right? Going out and in. Also, coroutines are not called this way. They're not normal functions. They have a special way, special function that is really running them. To address them by name, that's the way to start the coroutine. Blink is our function. This is our code. Let's save this and let's test. Compiling. Now you see that it's slower. You can see the change. It's not a jump. You want to see it even slower. Instead of returning null, you can return new, wait for seconds, and you can say that you want to wait 0.1 second. Right? Again, saving, jumping back, and playing the game. Now you can see it slowly, right? You want your thing to blink. Basically, what you have to do, you have to repeat this loop a few times. What I will do, I will make sure that we are going from 0 to 1, and we are doing it 2 times or 3 times. I less than 3, I plus plus. I'm going slowly down, then slowly up, and I repeat, right? And I have this yield return in both loops, right?
On the second loop, I guess you have to change your iterator, right? To plus.
Yes, thank you. Right. Okay, let's save. Let's test. And I'm back to normal, right? Now you can play with that. That's just a visual effect, but what you can do, you can attach some extra logic to it. For example, when you're blinking, you're immune, right, to enemies. Another thing that you can do with your with coroutines is spawning objects on, let's say, a time interval, right? So if I want to add rocket every number of seconds, right? I can do it with the coroutine. And coroutine can start itself or can start another coroutine if you want, right? So this way you can just keep adding. Let's do it. Let's go into our game controller. That's a good place to do it. I will add serialized field game object rocket. You may guess I'll be adding rocket every now and then. I will add a new coroutine to my class, right? So private enumerator add enemy. What I want to do first, I want to wait some time. Yield, return, wait for seconds. Just to make it quick, I will put a small number there so you can see how it triggers. Normally, you will put something longer, right? So you let the player to enjoy an easy setup, and then you increase it with some step. You can make it even random, right? So spawning a new rocket maybe maybe on a random interval. So first, I'm waiting. Second, instantiate rocket. Done. What I have to do, I have to call this this coroutine. Where? Well, I will start immediately, right? So I will start in initialize. After we've done everything else, we'll start our coroutine and make sure that make sure that our game is increasingly harder, right? We'll do that because our coroutine that is started here will not only instantiate the rocket, but also will start itself again. So we'll see more and more rockets added to the scene. You want to see it? Let's do it.
Right now it's just
Compile error.
Once, right?
Sorry?
Right now it's going to just be called once, right?
It is using the prefab, right?
Okay, so just now it's
But it tells me that we are using the prefab, right? And that's something that we have to do in the Unity last step that we always forget. At least I do. We need to give it a prefab, right? As a parameter. Let's see now. See? More and more and more rockets, right? Every 30 seconds, I have a new one.
10 seconds, you cannot go anywhere.
Well, you can play with this number, right? What you can do if you want a random intervals, you can do this. Let's say between 1 and 10 seconds. That's more reasonable, I guess. I have 1. Now I have 2. 3.
You can see over there all the objects being added.
Sorry?
And you can see on the left-hand side the objects being added by the game engine itself. On your game objects, they're being listed as long as they get into the scene. They're being listed there.
Yeah, you see them popping in the hierarchy, right? If you play your game and you switch to the scene, right? Obviously, you won't be able to control, but you'll be able to see all those objects as they appear. Right now, you have 2, 3, and so on. Why I'm showing that? Because that's also a way how you can implement shooting. You have a prefab. If you configure the prefab the same way we did with the rocket, right? So there is a script attached that is moving the object. You have some logic, what happens when it collides with, well, in this case, when you're shooting probably with enemy, right? If your object is equipped with all that, the only thing that you're doing when you press the space or other button, you just instantiate the object. And the object will know what to do, right? The same way that our rocket knows what to do. Because when it appears in the scene, the first thing that it does is reset, just go down. So that's one thing that I wanted to show you, coroutines. And they will be useful in your assignment, and they will be useful in, especially in your project, right? Another thing is, on Blackboard, I posted a list of exercises that you can do before the midterm, right? One of them is splitting a class that right now is altogether the game controller. Right? This class is right now responsible for two things. One is keeping track of points. The other one is maintaining a UI. I don't like this approach, because it means that class has a dual responsibility, and it's wrong. It's wrong from the software engineering point of view, right? The best practices say that when you design a class, you should design it in a way that it has a single responsibility. This way, you can put the class in a new context, right? And you don't drag this overhead with you, and you don't depend on the stuff that is not needed, right? So what I want to do right now, I want to create an additional class, a player, a singleton that will keep track of points and lives. And the player will take over the responsibility from the game controller. Also, the player will be this class that can be carried over to other levels, right? But game controller, in this case, is very specific for the scene. The name game controller is probably not the best one here. It should be UI controller or something like that. But well, it is specific for this particular scene, right? If you will have a new scene, maybe with different UI, you may like to change the class, right? So let's do that. I will add a new script. Create script player. Here's my script. And to be honest, I don't need this script to be mono behavior. I won't be attaching it anywhere. This will be a regular C# class. Right, so I don't need start and update. Bye-bye. I told you that it will be a singleton, right? Remember what singleton is? A class that has only one instance in the whole system, right? So we'll implement it in a way that it cannot be instantiated anywhere else, just inside this class. And we do it simply by implementing a private constructor. Constructor can be empty, but why we are doing it to remove the default one, right? So that's one thing. Another thing that we need ability to store this one reference that we want to have, right? So static private instance. Private what instance? Player instance. And we'll turn it into a property, right? So we'll have static public player instance. Don't help me. There will be a getter. We don't need a setter, just a getter. Getter will check if we have instance. It was created already. If we don't have it, then we have to create one. Right? We instantiate the player. In all cases, because it's a getter, we have to return value. So we have the private constructor, which means nobody else can create the instance of this class. and we have this single source or single access point to the instance, which is our getter, our public public property, right? These two things have to be static, otherwise it doesn't make sense, right? Because they have to be called from the class, not from the object level. If you make it static, you make a class that cannot be instantiated anywhere, right? Because the only place where you can access it is inside the class, so it's useless outside. Okay, now we need two things that are already implemented in our game controller. Again, I told you that I'm lazy today, and I will simply cut this stuff from here. And we'll paste it in here. I need life and I need score, right? I don't have access anymore, direct access to the to my UI, right? What I will need to talk. I will need to talk to the game controller. It should be property. I'll just make it public to save a little bit of typing. To this guy, I'll be able to access game over. But I will also add a new function. I will add function update UI. It's not there yet, but I will add it in a second. Right? So update UI will replace this line where we are setting the text for the labels. Right? Hey, I'm saving this. I'm jumping back to the game controller. All right, in game controller, I have to do a few changes. First, game over is private. Now I'm calling it from the player class. Make it public. Let's add another public function, update UI. This function will do what we used to do manually before, right? To update the player, the score and life tables. Now, this is not our variable anymore, but what we'll do, we'll ask player to give us this information. Right now, player, the instance of the player, is the source of our information about score and life. So one thing done. But it won't work unless the player knows the controller, right? So the controller has to introduce himself. That's how we do it. We're saying that the player instance G-controller, right, should be talking to this guy here, the game controller. Now we have connection both ways, right? Because the player, the player knows the controller, right, and can call some functions from there, and the controller can get information from the instance because they have public properties. right? Fast change. We've been using game controller in plane collision to change lives and scores, right? We have to fix this. So we have to say player instance instead. Two places, right? One is when we give extra points. The other one is when we when we take lives. Let's save everything. Let's build. Let's fix remaining issues. Good. We can test. Really, nothing should change in our game. We are doing exactly the same things, right? We've changed the structure of the program, but from the user point of view, it should be exactly the same. Right? So if something is different, then it means that we messed up. Right? Okay, there is one thing to be added, the storing the high score. But I decided that we'll look at it after the midterm, right? So that will be the first thing that we'll do after the break that we'll have. For now, that's it. That's all the material that we need for the midterm. I will stop the recording, and then we'll talk about other things. Okay.